concentration term, that is strength. What is strength? Strength is mass of solute per or upon volume of solution in liter. This is another concentration term. Strength. Strength is expressed as S. Okay? Now you will see, what is molarity? Molarity is number of moles of solute upon volume of solution. So I will take it in liter as well. Okay. So this is written as, number of moles of solute can be written as mass of solute. Nehru beta, do you know about this part? The number of moles का formula क्या होता है? It is mass of solute upon molar mass of solute. Multiplied by volume of solution. Tell me. Yes, Nehru बच्चे, Nehru प्रखर, आपको पता है बेटा, what is the formula of molarity, what is the formula of number of moles? पढ़ा है या नहीं पढ़ा आप लोगों ने? So this is mass of solute upon volume of solution. So this will be strength. This is strength, and molar mass of solute is written as m naught. So this is the relation between molarity, strength and molar mass. They can ask you a question over here. Okay. Similarly, now normality is molarity multiplied by n factor. So this will be S by m naught into n factor, which I can write as strength upon m naught by n factor, which is equal to S by E. What is E? E is equivalent mass. बेटा अगर नहीं अभी फॉर्मूले क्लियर हो रहे हैं ना, तो आप प्लीज एक बार नोट कर लीजिए. आपको मैं अभी जैसे और भी बच्चे ज्वाइन कर रहे हैं ना, सो आई विल टेक सम एक्स्ट्रा क्लास जिसमें आई विल स्टार्ट फ्रॉम स्क्रैच. आई विल स्टार्ट फ्रॉम जीरो, आई विल कंप्लीट दैट पार्ट एंड देन वी विल गो अहेड. ओके, सो डोंट वरी. ओके, जस्ट टेक डाउन द नोट्स एटलीस्ट. कि आए हैं क्लास में तो नोट जरूर ले लीजिए. सो द फॉर्मूला बिकम्स n इज इक्वल टू S बाय E. रिलेशन बिटवीन स्ट्रेंथ एंड मोलारिटी, स्ट्रेंथ एंड नॉर्मेलिटी, ये पूछ लेते हैं आप लोगों से. एवरेज एटॉमिक मास. You see, what is the concept with mass? See, we say that atomic mass is equal to number of proton plus number of neutron. Let me in grams. Fine, this is how we write. Okay. So, if I talk about chlorine, the mass is 35.5. Okay. It is one and the same thing, beta. When you say atomic mass, molar mass, mass number, now it is one and the same thing. Don't worry about it. Okay? You simply say when you only use the word atomic mass or mass of one atom. Now you have grown up. Now you know कि when we are talking about atomic mass, we are not talking about the mass of one atom. We are talking about the mass of 1 mole of atom. If it were atomic mass, instead of gram, I would have written U. If it is gram atom, or I can write gram atomic mass. Instead of gram atomic mass, I may simply use molar mass. The idea is that we should be doing the measurement in grams. If it is about one atom, then you should be using U, that is atomic mass unit. Clear? बेटा पढ़ाया होगा स्कूल में तो बताएंगे ना, समझा करो बात को. वो बहुत बेसिक लेवल की बात बता रहे हैं तो वहां तो होगा ही, वहां डेफिनेशंस आपको लिखनी पड़ेंगी. There you have to talk about definitions. Okay, when you say mass number, it is a number wherein you are talking about number of protons and number of neutrons. To get the molar mass, just add G after mass number. When they say atomic mass, that is the mass of one atom, you have to measure it in atomic mass unit. यही बताया है. Okay. Now, what is the fact? See, Dalton's atomic theory said that atoms of an element, or rather all atoms of an element are same. Okay? But this is wrong. Why is this wrong? Because of the concept of isotope. Now what are isotopes? Same atomic number but different atomic mass. Or in very simple words, atoms of an element having different number of neutrons. Very, very simple words. Yes, it is not a bit when the basics are not. See, this is the basic atomic theory. When it is atomic, so how come I can apply it to reactions? This point is wrong. So, isotopes, there is same atomic number but different atomic mass, or atoms of an element having different number of neutrons. ठीक है बेटा? So now the point is, what happens in a given sample? Now this is very important. This is very important point, that in a given sample, the percentage of each isotope is fixed. So this is how God has helped us in calculation of average atomic mass. So now what I may simply do is, I'll say average atomic mass is equal to percentage of first isotope into its mass plus percentage of second isotope into its mass. Now you see, chlorine has got two isotopes, Cl37 and Cl35. In both the cases, now number of proton is 17. Proton 17, proton 17. Neutron 20, neutron 18. So you see the difference is in the number of neutrons. Alright? So now how do I calculate the average atomic mass of chlorine? So average atomic mass of chlorine is equal to, what is the percentage of first isotope? This is 75%, this is 25%. Now see, you can write it in two ways. Either you can write 75 by 100, that is your choice. I prefer to write 0.75. मुझे लगता है ऐसे कैलकुलेशन इजी है, तो आप, इट्स योर विश, यू कैन राइट द वे यू वांट. प्लस 0.25 into 37. On solving, you get 35.5 gram per mole. This is the average atomic mass of chlorine. अभी किसी ने पूछा था ना मुझसे स्कूल में, तो they can ask you a question on this. NCERT की बैक एक्सरसाइज में है ऐसा क्वेश्चन. ठीक है, फाइन, ओके, फाइन. नाउ सिमिलरली वी हैव गॉट H1H, H12, H13. This is termed as protium. This is termed as deuterium, represented by D also, and this is tritium, represented as T also. You got C12, C14. You got iodine 127, iodine 131. Okay, these are a few other examples of isotopes. Now, another term, what are isobars? Now, these are atoms of different element having same number of nucleons, that is same number of proton plus neutrons, or same atomic mass but different atomic number. For example, there is an isotope of sulfur which has got mass 40 as well. This though is very rare, so these are the ones which you can easily find. Argon, potassium, calcium, it's like 18, 19, 20. Atomic number is different, but atomic mass is same. Or you can also have 6C14 and 7 14. The lower one is atomic number, which is equal to number of protons, and the upper one is atomic mass. isotones, atoms of different elements having same number of neutrons. For example, boron 13 and boron 12 and carbon 13. Now this is 5, this is 6. Now you see, number of proton is 5, number of neutron is 7, number of proton is 6, number of neutron is 7. So these two are isotones. अभी आपने पूछा तो मैं बता देता हूँ. Helium has got a large number of, see this is 2He4, which basically says that there are 2 neutrons and 2 protons. But you can also have 2He3. There are certain radioactive isotopes which are 2He5. There are 2He6. These are radioactive. Now this is the most abundant. Okay, it is 0.0002% only. Using mole concept. Okay, so now it's all about numerical and how to solve them. So I'll pick up the numerical and I'll tell you how to solve it. Okay. So let me start with the basic one. Rather than going to the illustrations first, let me go for the basic ones. So the question is, calculate the mass of NaOH required for complete neutralization of 73 grams of HCl. Okay. Now, so this is a very simple question. How you have to start with it? First of all, check over here what all are reacting. HCl and NaOH are reacting. HCl plus NaOH gives NaCl plus water. Okay. Fine. Now this is the equation. You have to balance this equation also. These are very simple equations. You can easily balance. When it comes to the redox reaction, where the balancing is a bit tough, I'll teach you how to balance the redox reaction also. Okay. So I will cover your 8th chapter, which is in the second book of NCERT, the redox reaction. I'll cover over here only. Along with this chapter only, I'll cover that part. Okay? Fine? So that we know the balancing part as well. So first thing, write the basic equation, how you have to balance it. Okay? Now, the mass of this is given, but the mass of this is being asked. Okay? Now, before I even go to the mole concept, let me solve this question by using unitary method. Now what does unitary method says? What is the molar mass of HCl? 36.5. grams. What is the molar mass of NaOH? 40 gram per mole. Okay. So how I may solve it out? I'll say 36.5 gram of HCl requires 40 gram of NaOH. Okay. So 1 gram of HCl requires 40 by 36.5 gram of NaOH. So 73 grams of HCl would require how much? 40 divided by 36.5 into 73 is equal to 80 grams of NaOH. Okay. So you got 80 grams of NaOH. Now, as they are asking in the question that you have to find out the number of moles, so you will say number of moles of NaOH is equal to 80 grams divided by 40 gram per mole is equal to 2 mole. This is the answer. Now this is while you are solving it by unitary method. Okay. Now let me use mole concept. Okay. Fine. Now mole concept says that, see, as per the balanced equation, number of moles of HCl is equal to number of moles of NaOH. You see, both are 1. 1 mole of HCl requires 1 mole of NaOH. The number of mole is 1. Now, how many moles of HCl are given over here? The mass is given to be 73. The molar mass is 36.5. Right? Okay. Gram per mole is equal to mass of NaOH upon 40 gram per mole, which is the molar mass of NaOH. Now when you solve it out, mass of NaOH comes out to be 80 grams. Tell me. So there are 2 ways by which I have solved this question. You can solve it the way you want. See, this is the balanced chemical equation, right? Now as per this balanced chemical equation, you can see that there is 1 mole of HCl and 1 mole of NaOH. So there are equal moles of HCl and NaOH in this equation. So I am saying number of moles of HCl is equal to number of moles of NaOH, because as per the balance equation they are equal. Okay. So now simply for HCl, mass is given 73, molar mass you know. Here you have to calculate the mass. Molar mass is already known. So this is the answer. Okay. Now suppose instead of this, the question would have been this. अगर ये ऐसे होता, now can you guys solve this question? Suppose if this is the problem, can you solve this question by unitary method as well as mole concept? Try it beta. Solve it once again. ओहो, गलती कर दी. The given mass is 196 gram. Now see over here beta, when you are balancing the equation, you have to put 2 over here. Then the equation will be balanced. So that is why there is a difference between this method and this method. I mean this question and the previous one. Okay. How many people are not able to solve by unitary method? Now see, 98 grams require see, this is the answer for the first question, I mean the first way. Is this clear to everybody? Now let's check it out. How do we solve it over here? Now see, listen to this very carefully, bache. Very, very carefully. Okay, how many moles of H2SO4 are over here? 1. How many moles of NaOH are over here? 2. So can I say number of moles of NaOH is 2 times the number of moles of H2SO4. Okay. Now mass of NaOH is what I have to calculate. Molar mass is 40. What I have given over here is 196 gram. Molar mass of H2SO4 is 98 gram per mole. So what is the mass I am going to get? 98 into 1, 196 is 2. So 2 into 2 into 40, which is 160 grams. Answer. Clear? Ideal gas equation. Because for solids you may talk about mole concept. For liquids you can talk about solutions, but for gases you have to talk about ideal gas equation. Now what is this ideal gas equation? This ideal gas equation is PV is equal to nRT. Now let us segregate. What is P? P stands for pressure exerted by gas on the walls of container. ठीक है? A gas on the walls of container. Now, what is the unit of pressure? It can be 1 atmosphere, which is 1.01325 bar, or 1.01325 into 10 raised to power 5 pascals. PA stands for Pascal, or 1.01325 into 10 raised to power 5 Newton per meter square. Okay, or it can be written as 760 millimeter of Hg, or can be written as 760 torr. Torr comes out after the scientist Torricelli. So these are the units of pressure. You have to remember all. Okay. What is V? V is the volume of container. Please remember, gases की कोई volume नहीं होती है. So 1 meter cube is equal to 1000 liter, or 10 raised to power 6 milliliter, or 10 raised to power 6 cubic centimeter cc. Okay, fine. Also you can write 1 liter is equal to 1000 milliliter, or 1000 cc, cubic centimeter. Okay. N is number of moles, you have already done. R is universal gas constant. Now this is a very tricky stuff. Universal gas constant. देखिए बेटा, इसका वैल्यू फिक्स रहता है बट यूनिट्स के साथ चेंज होता है. R can be written as PV upon NT, right? देखो, PV upon NT लिख सकते हैं. Okay? So the value of R will be 0.0821. Please listen to me very carefully. बहुत important point है. ये value R का कब होगा? When the pressure is in atmosphere. Volume is in liter. Pressure in atmosphere, volume in liters per mole per Kelvin. If suppose instead of atmosphere you change it to bar, then it becomes 0.083 bar liter per mole per Kelvin. Okay, and this becomes equal to 8.314 if the pressure is in Newton per meter square, volume is in meter cube upon mole per Kelvin. So this is 8.314. See meter square, see this is Newton per meter square into meter cube. So this will cancel, so you will get Newton meter. So this is, and 1 Newton meter is equal to 1 joule. Okay, so this is joule per mole per Kelvin. Okay, fine. And what is this T? T is temperature. T stands for temperature, where degree Celsius is equal to 273, or the temperature should always be in Kelvin. And please remember beta, this Kelvin is capital K, don't write it as small k, is equal to degree Celsius plus 273.16. Okay. Now you normally do not use 0.16. So suppose if it is 27 degrees Celsius, this will become 27 plus 273, which is equal to 300 Kelvin. So that's what I have written, capital K, capital K, capital K, Kelvin. Okay. So this is the ideal gas equation. Most important part is the value of R, which you should remember. ठीक है?